Hey, welcome back to Math with Patrick and Quill today. Uh, Today is September 16th, and we're solving problem 259 from the Daily Epsilon calendar. And we need to show why x is supposed to be 16 today. All right, so we have an equation. We have x to the power of x is equal to 2 to the power of 2x plus 32. One good practice for these kinds of problems where we have like exponents and like a variable in our exponent is to try to match the bases. And normally these problems look a bit like this, where we actually know what our bases are. So it's a little bit strange that we have an x in place of our base. So that's leaving me with some ideas where like maybe we both know x is 16 today, but I would guess maybe x is supposed to be 2 or 4 or 8 or 16 or 32, because those are all like fairly easy bases to convert between, with 2 being the other number here. Like for example, just to use another number as an example, I could convert pretty quickly between like 3 to the power of x and 27 to the power of x. Let me just throw on like a little plus 3 there to like try to solve this equation. Essentially what I would do here is I would just rename that 27 as 3 cubed, and then I would use an exponent rule here where I could multiply these stacked exponents, and then so I would get some kind of equation here where now that the bases are the same, I could just look at the exponents and solve. So I basically just want to like guess a few different powers of 2. Clearly we're going to get there eventually, and just see what happens when I set x to be that number. And I guess, if I just pick x to be 2, I could just fill in all of these spots. And then clearly 2 squared is not the same as 2 to the power of 36. So we could keep guessing, and then like say now I decide that x is 4. On the left-hand side, I would need to rename this 2 as a 4 to try to match the bases. And I know that I could maybe square root 4 to get 2. Thinking about this in terms of exponents, I can use fractional exponents for that idea. So then I could, I still have the number 2 right here. And I could play the same game where I multiply the exponents. And so I'm questioning here if 4 to the power of 4 is the same as 4 to the power of x plus 16. And here we already set x to be equal to 4, so this is just a 20, and clearly 4 is not the same thing as 20. However, it seems like we're getting closer, because remember how it was like a 2 and a 36, I think? And so the exponent on the left-hand side is getting greater, and the exponent on the right-hand side is getting smaller. So we could just keep trying this and see what happens. 8 to the power of 8 would be next. I would have to write this as the cube root of 8, or to the power of 1/3 is fine. So now that our bases match, we can see if our exponents match. So this exponent here is just an 8. And then distributing that 1/3, again, using that exponent rule that I can multiply them, I have 2/3 x plus 32/3, I guess. Oh, and then x is 8 in this example, so we would get 16/3 over here, 32/3 over here. That's going to be 48/3, which is the same thing as 16, I think. And then that is not the same thing as 8. So the next thing to try would be the next power of 2. But again, these are getting closer, right? This 8 is getting closer in value to the 16. And so to me, this suggests, we're getting closer to finding an answer. So let's see what happens when we put a 16 in for x. I would need to take the 4th root of 16. So I would put a 1/4 here. And then now that the bases match, I can compare the exponents. Multiplying the 1/4, I get 1/2 x plus 8. X is 16 in this example, and half of 16 is 8. And so we do indeed get a match. And so this does tell me that x is supposed to be 16. Yes, this was the last 16 that I needed to plug in. Maybe that's a little unsatisfying though, because I was using guess and check, but I was using it strategically, right? I was guessing powers of 2 for x, but like if I didn't hit an answer, I don't know what I would have done. Like maybe we could do some algebra steps on it. I just wanted to investigate this before we finish the video. Like usually when you have, you know, variables in the exponent, you can use a logarithm to kind of simplify it. And so I could rewrite this with logarithmic notation instead. I could take maybe a log base 2 of both sides, and that would knock out this guy. And so I get 2x plus 32 is equal to log base 2 of x to the power of x. I could use another log rule that lets me take this exponent out front as a coefficient, or I guess just a factor in this case. And then if I really wanted to, maybe I could divide both sides by that x now. I don't really know where I'm headed. I'm just trying things out. And then maybe I could distribute that denominator, and maybe this is going to tell me something. Let's see. So on the left side, I know that as I keep increasing x, this value overall is going to get smaller, right? It's going to be 2 and then plus some positive number. But as x gets bigger, this fraction gets smaller. And so I know that, like, it's going to be a little bit above 2, but as x gets bigger, the end behavior is it's getting about equal to 2. Whereas over here, logarithmic equations or functions grow forever. I mean, they grow very slowly, but if I increase x, the value of this is also going to increase. And so looking at this equation, at least, I can tell, like, as x gets bigger, the left-hand side, I'll say L for left-hand side, approaches 2 from the positive side, whereas the right side approaches infinity. And in particular, this value right here is always decreasing. This value is always increasing. So I do know from this equation that I'm going to get one and only one solution, because, if we have something that's decreasing always and something that's increasing always, then it should intersect at just one spot. And so this x value would be still 16, because we're, solving for that same value for x. And I guess in this case, my y value would be 4. I'm just kind of imagining what would happen if I plugged in a 16 in either of those spots. So I guess that's the other thing that we could have done with this, like kind of change the form of it so our guess and check looks a little different. Either way, I'm able to solve this, and I know that there is just the one solution, and it is 16 for today. So thanks for watching. We're all done. I'll see you tomorrow. Bye.